Yo, this Coach Ray, back at it again. Here's what this video is. It is the end of the Radical Review notes. The Radical Review notes had a ton of information on them, 9 total examples. The first video has the first 8 examples. Number 9 is the hardest of the 9 problems, so I wanted it to have its own video. So example 9, without further ado. Okay, I real quick want to look back at example 8. Example 8, just a reminder, we did this. We said it's the same thing as square root of 2 over square root of 7. And normally we'd be okay with that, but we talked about there's a simplification rule that says we can't leave crap in the denominator, and the square root is one of those things. So if something is not simplified if it has a square root in the denominator. Okay? So in order to get rid of it on this problem, it was pretty easy. I just talked about how we had to multiply by the square root of 7, because square root of 7 times square root of 7 will be square root of 49, which will then turn into a normal 7. Okay, but I can't just multiply the bottom by square root of 7 because I want to. In order to stay out of trouble, I can multiply the top as well. Now I just multiplied the whole blue thing as 1. So I can multiply something by 1 and it doesn't change it. And so we ended up with an answer here of square root of 14 on top, and square root of 7 times square root of 7 is square root of 49, which turns into a whole number 7. Okay, we were done okay. All right, the reason I want to mention that is because it kind of leads into the problem with number 9 and why it makes number 9 weird. I look at number 9 and I see this binomial in the bottom, 4 square root of 2 plus 2. And those are not like terms. This is kind of the same thing as 4x plus 2. I would not be able to combine those. I would just have to leave them. Okay? So now I'm trying to just strategize, how can I get that square root of 2 out of the denominator? That's the only bad part about the denominator. My first thought would be to multiply the denominator by square root of 2. Because if I multiply the square root of 2 times the square root of 2, it'll turn into square root of 4, which will turn into a normal 2, so that sounds good. But the problem is, because this is a binomial on the bottom, I'd have to multiply both. So yeah, it would get rid of this guy, but when I do square root of 2 times this 2 in the back, that would just end up being 2 square root of 2. So I'd get rid of the front one, but I'd create a new square root on the other side. So I need a new way of doing this. Okay, here is a new word for you. It's called, if you say it as a verb, it's conjugate. And if you say it as a noun, it is the conjugate. Okay, so we are going to multiply by the conjugate. Here's how the conjugate works. I'm going to take this binomial, and I'm going to multiply it by another binomial. Okay, the other binomial is going to be 4 square root of 2 in front, 2 in back. So notice the numbers are the exact same. The only thing I change is the sign in the middle. If the original sign in the middle was minus, I would change it to plus. Okay, so the only thing I'm changing is that sign in the middle. So what this should look like is difference of perfect squares. Okay, when we factored and we had like a plus b and a minus b, that's part of why this ends up working. Okay, I'm just going to do it now because we already talked about it. Over in example 8, when I multiplied the bottom by square root of 7, I had to multiply the top as well so that it was 1. Same thing over here. So I'm going to multiply the bottom by something, I got to multiply the top by the same thing. So same signs and everything. So I need that to just be 1 over there on the side, even though it's a very fancy looking 1. All right, let's start multiplying. I'm going to do the bottom first because the bottom gets ugly quick. All right, I have a binomial times a binomial. There's a 4-letter F word that we use to multiply binomials. It is FOIL. Okay. First is this one right here. Remember, outside people mess with outside people, inside people mess with inside people, but they can't mess with each other. No outside people can mess with inside people. So the outside, 4 times 4 is 16. Inside, square root of 2 times square root of 2 is going to be square root of 4, which I'm just going to turn into the whole number 2. Okay, there's my first. My outside, okay, 4 square root of 2 times negative 2. Those are both, I can multiply my outside people, and my inside person just stays the same. So 4 times negative 2 is negative 8, and then I've got my square root of 2. Same thing with my inside here. My outside people can multiply, so positive 2 times 4 is positive 8, and then I got my square root of 2. And finally, last, positive 2 times negative 2 is negative 4. All right, so I got a big old ugly denominator now. I'm going to let that chill for a second. I'm going to do my numerator right now, and then I'll clean things up afterwards. All right, so let's see. Here's my fraction bar. Let's see what I got up top. Up top, I just have negative 5 times this, so that's just distributive product. Okay, so negative 5 times my outside guy, that's negative 20. Then I've got square root of 2. And negative 5 times negative 2 is positive 10. Okay, I want to pause. Everybody okay? Questions so far? Super ugly at this point? Yes?
Where'd you get the times 2?
What?
Is that from?
Where?
Just 16 times 2. How can you get times 2?
Oh, the question is, where did the 2 come from in the blue 16 times 2? That came from this first. I did 4 square root of 2 times 4 square root of 2. But specifically it came from, when I did the square root of 2 times the square root of 2, I got square root of 4. And I automatically switched my square root of 4 to the whole number 2. Good question. Alright, I'm going to start cleaning up. On the bottom, 16 times 2, that is 32. Okay, check this out. Negative 8 square root of 2, positive 8 square root of 2. Are they like terms? Yes, because they both have square root of 2, and square roots act as variables. So that's kind of like negative 8x plus 8x since they have the same square root. So negative 8 square root of 2, positive 8 square root of 2, they just cancel each other out. That's the reason conjugates work, is because those two middle terms with square roots cancel each other out always. Okay, so then I'm left in the back with minus 4. All right, let's look at what I got on top. Negative 5 times 4 square root of 2. Oh no, I already did that. Sorry, that's this green part. So negative 20 square root of 2 plus 10 on top. All right, I'm going to just change this to be negative 20 square root of 2 plus 10 all over 28. 32 minus 4 is 28. All right. At this point, I got to look to see if I'm done. And I'm not. I would hope that you notice there's a whole bunch of even numbers up there, yes? Okay. So we can probably reduce, at least by 2. All right? So when I'm looking at this, only outside people mess with outside people, inside people mess with inside people. Okay, so my square root of 2 is the only inside person. That's not changing. He's got no one to mess with. But all of my outside people are divisible by 2. All right? It's important that all of them are. Okay? So since they are all divisible by 2, I'm going to reduce all of them. So my answer coming this way is going to be negative 10 square root of 2 plus 5 all over 14. Okay? And that is an answer. And I just want to mention right now, that's a little bit different than how I taught all my other classes. And I'm going to teach you how I taught all my other classes as well. The reason I'm doing this right now is I learned today that Alex wants you to write this answer as one fraction, which is weird to me. I actually think that's the only weird thing I found about Alex. But Alex wants this as one fraction, and that's how you do it. Here's how I would do this. Okay, I'm going to move over this way. I'm going to take my negative 20 square root of 2 plus 10, and instead of it all being over 28, I put each one over 28. Okay, and in fact, I advise you to do that all year. Whenever you have multiple numerators and one denominator, put them all over that denominator. I think it's much easier to visually see kind of what's going on. All right, so now when I reduce, check out this 20 and this 28. What goes into both of those? 4. Okay, so now this would be negative 5 square root of 2 over 7. And this would, and now these would just simplify by 2. So this would be plus 5 over 14. In my personal opinion, this red answer is simpler than the green answer, but Alex disagrees with me. Okay, but your test is going to be on Alex, so Alex is going to want the green answer. Okay, so you'll see that when you get to those problems. All right, that's it for today. Time for the outro. Yo, yo, yo. Taking it out of here. Getting back to work. All right, it's been real. I'll see you guys in the next video.